Welcome back. We didn't quite make it through the second example problem for KVL and KCL, but I do want to give you this example problem because I think it might help you on lab 3. So I'm just going to record this and then I'm going to post it and you can watch it. I'd recommend trying to do the problem before you watch this video because I think that will really help you out a lot. So try to do that example problem that I gave at the end of class today on Monday, and then watch this video and we'll go through how to solve it. So let's go ahead and I will assume that you have tried to solve it. So now I'm sharing my screen. So here's the example problem that I gave at the end of class today on Monday. And these are all the givens. And we need to solve for basically all of the current and voltage values. So we look at this, and according to our procedure, we try to see if we can solve it using the method of R total, because if so, we can use that, and it's maybe a little bit easier. So we look at this, and we say, is there anything here I can combine in series or in parallel? And the answer is really nothing. There's really nothing here that I can say are in series or parallel with anything else. So pretty clearly the answer is no. I can't use the method of R total on this circuit. So I'm going to have to use KVL and KCL equations combined with maybe Ohm's law, maybe voltage divider. So in order to do that, I need to make sure everything is labeled. And most things were already given to us as labeled. We got nodes, A, B, C, D. We got resistances, 1, 2, 3, 4, V sub L, V sub R. Really, the only thing we need to add to this are the assumed current flow directions. And we need these so that we can write the KVL and KCL equations. So once again, it doesn't really matter which direction your arrows are. So let's just go ahead and I'm just going to write in some arrows. I'm going to assume that I1 goes this way, and I'm going to assume that I2 goes this way. And I4, I really don't know, but I'm going to make the assumption that I4 goes this way. But again, these are really just guesses. And if you end up guessing the wrong thing, it just ends up being a negative number, but that's totally fine. Just leave it like that. All right, so now we've got everything labeled, and now we're starting to try to write KVL and KCL equations. For KVL equations, we're trying to find a loop with one unknown voltage drop. For KCL equations, we're trying to find a node with one unknown current going into or out of it. All right, so what do we know here? What do we know? Well, we know V sub R, and we know I3 and R3. So the first thing we should probably do is we can find V3. Let's go ahead and do that, because we don't even need KVL or KCL to do that. So we can do V3 equals I3 R3. And I3 is given as 3 amps. And R3 is 4 ohms. So 3 times 4 is 12. Amps times ohms gives you volts. So V3 is 12 volts. And while we're here, we can also fill in for I3 because we were given that was 3 amps. Okay, so now we know everything there is to know about component 3. We know I3, we know V3, and we know R3. We also need to figure out what we can do next. We need to figure out what we can do next. So what do we know? We know everything there is to know about this, and we know everything there is to know about this. So it looks to me like we could make a loop right here where our only unknown voltage drop is this from here to here. So that's what I would do next. Let's make a KVL loop. I could probably fit it down here, but I'm just going to make a new page. So I'm going to make a KVL loop, and I'm going to call this the lower right loop. And I like to go with the arrows as much as I can, if I can. So I'm going to go counterclockwise here. And it doesn't matter where I start. Let's just say I start at A and I go counterclockwise. So I'm going with the arrow here. So I take positive V2 And then I'm going with the arrow here. So I take positive or plus V3. And then I get over here and I come to the negative sign first for V sub r. So I take minus V sub r. And then I get to where I started from. So I set it equal to 0. I'm trying to solve for V sub 2. That's the unknown. So I want to get V2 by itself. So I'm going to add V sub r to both sides and subtract V3 from both sides. So V2 equals VR minus V3. And I know what both of those are. VR was given as 20 volts. And V3 we just solved, and it's 12 volts. So subtract 12 volts. So V2 equals 20 volts minus 12 volts, which is 8 volts. All right, so I can write that down. V2 is 8 volts. And once I know that, I can find I2 because I know V2 and R2. So I can say I2 equals V2 divided by R2. V2 was 8 volts. R2 was 2 ohms. And 8 divided by 2 gives me 4. Volts divided by ohms gives me amps. So I2 is 4 amps. All right, so now I know everything there is to know about this component and this component and this component. And I don't know everything there is to know about that one or that one or that one. So this is a point in the problem where a lot of people get stuck because for some reason there tends to be a tendency to look for loops first. I don't know why, but I do the same thing. So you're looking for a loop and you try to find a loop where there's only one unknown. So maybe you look for this loop, but that won't work because these are both unknown. And we can't solve one equation that has 2 unknowns. It won't work. It's like saying x plus y equals 5. I don't know what x or y are. And I might try this loop right here, but that won't work because these 2 are unknowns. And I might try the full outer loop, but that won't work because these 2 are unknowns. So try as you might, you will not be able to find a loop here with only one unknown. So if you can't find a loop with one unknown, maybe you can find a node with only one unknown current flow. So you look around to different nodes. Maybe you look here first and you say, well, I don't know what this current is coming in here. I don't know what this current is here. I don't know what that current is. Over here, I do know what this current is, I2, but I don't know this current in this branch or this current here, so that doesn't work. Down here, that wouldn't work either, because even though I do know this current, I don't know the current here or here. But then maybe you look at B, node B, and you think about what's known and what's unknown here. And if you think about this, you'll realize that you do know I2 coming in here, and you do know I3 coming out of here, which leaves just one unknown right here for I1. So we can proceed by writing a KCl equation at node B. KCl equation at node B. KCl says the current coming in equals the current coming out. So on the left side of the equation, write all the currents coming in, add them all together on the left side of the equation. So what's coming in to node B? We got I1 and I2 coming in to node B. So I1 plus I2, and then set that equal to the currents coming out of that node. So coming out, we just have I3. So set that equal to I3. And now the only unknown here is I1. So I'm going to rearrange this equation for I1. To do that, I'll subtract I2 from both sides. So I have I1 equals I3 minus I2. And I can plug in values now. I3 was 3 amps. And I2 was 4 amps. So look at this. We're going to get a negative number. And once again, I may have done that on purpose to show you that it's totally fine and to show you what I want you to do, and you get a negative number. And that is just write it in exactly like that. I1 equals -1 amp. So write that in just like that, which actually means that in reality, our current through resistor 1 is actually going from right to left, and it has a magnitude of 1 amp. Okay, but just leave it like that. Just leave it exactly like that. Okay, and then we know I1 and we know R1, so we can find V1. V1 equals I1 R1. I1 we just found was -1 amp. R1 is 3 ohms. So -1 times 3 is -3. Amps times ohms is volts. So V1 equals -3 volts. Okay, V1 is -3 volts. All right, what do we got left? We've got this unknown, and we've got this unknown, right? All right, so we have V sub L, and we've also got V4. We don't know that. But actually, we do know V sub R, right? That was given. I could just go write that down. VR was 20 volts. I could have written that down at the very start, but I didn't. All right, so this is unknown, and this is unknown. So what do we want to do next? Let's see if we can find some loops or nodes. So now we know everything there is to know about this, and this, and this, and this. So the next thing I'm going to do is make a loop over here, because I know everything about this, and I don't know that. So I can write a KVL loop over here. KVL for the lower left loop. And I want to go with the arrows, so I'm going to go clockwise. So where do I start? Doesn't really matter, but maybe I'll start up here at C. So I'm going to go with the arrow here. So I'm going to take positive V1 plus V3 minus V sub L equals 0. So I write that down. V1 plus V3 minus VL equals 0. And what am I trying to find here? VL. That's my unknown. So I bring that over to the other side of the equation, so it's by itself. So I get VL equals V1 plus V3. Now I can plug in numbers. V1 was -3 volts. Plus V3 was 12 volts. V3 is 12 volts. And -3 volts plus 12 volts is 9 volts. So VL equals 9 volts. All right, so I can write that in. And now the only thing left for the components is resistor 4. All right, so that's my unknown. And I could do a bunch of different loops. I could do the entire outside loop. I could do just this loop. I could do something weird like that loop, or really anything, any closed loop. But I don't know. I think I'm just going to do this top loop right here. And I think I'll go in the counterclockwise direction. All right, so KVL for the top loop, and I'm going to go counterclockwise. So maybe I'll start here at the upper left. So I'm going to go with the arrow here. So I write V1, then I go against the arrow here. So I write minus V2, and then with this arrow, so I write plus V4, back to the start. So I go equals 0. So I have, let me make sure I write this down correctly. We had V1 minus V2 plus V4 equals 0. All right, and now I'm trying to solve for V4, so I'm going to get that by itself. So I'm going to add V2 to both sides and subtract V1 to both sides. V4 equals V2 minus V1. And So we know what V2 and V1 are. V2 is 8 volts. V1 is negative 3 volts. So be careful here. There might be subtracting a negative number. So V4 equals V2 is 8 volts minus V1 is negative 3 volts. So that means that V4 is equal to 11 volts. Okay, and I can write that in right there. And now that I know V4 and I already knew R4, I can find I4. I4 equals V4 divided by R4. V4 was 11 volts. R4 was 1 ohm. 11 divided by 1 is 11. Volts divided by ohms is amps. So I4 equals 11 amps. Okay, I can write that in over here. Okay, and that's all the components. The only things left are the nodes. So I need to solve for those. So remember, I'm always going to use my reference probe, my black reference probe on ground. And then for node A, it's over here. So it's like I have my multimeter probes here and here. So the easiest way to get from ground to node A is through here, right? And when I do that, I gain 20 volts. So up here, the voltage is 20 volts. And it's actually 20 volts in the entire region up here on the upper right because there's no component to drop voltage up here. So the voltage up here is 20 volts. So I can write in voltage at A is 20 volts. Next is the voltage at B. So that's like this. Okay, so the easiest way to do that is to go through this component. All right, so that was V3. V3 was 12 volts. So I know that with the direction of the arrow, I'm dropping 12 volts from here to here. I drop 12 volts. And I also know, because this is ground, that this is 0 volts. So this is 0 volts, and I drop 12 from here to here. So what must the voltage here be? It must be 12, so that I can drop 12 here to here and be at 0 when I get here. All right, so this voltage at B must be 12 volts. Voltage at B is 12 volts. And then the voltage at C, this is another pretty easy one. The easiest way to get from ground to node C is to go through the left voltage supply. And when I go from the negative to the positive side, I gain V sub L, which was 9 volts. So the voltage over here at node C and in this quadrant, in this corner up here, is just 9 volts. So V sub C is 9 volts. And then the last one is really easy. If I'm going from here to here, well, there's nothing here to drop a voltage. So it's just 0. So the voltage at D is 0 because it's just directly connected to ground. All right, so I hope that was helpful. I think it will be. If you understand that example problem, then you should be able to work your way through Lab 3. That should make sense. As always, let me know if you have any questions. I will post another example video on Wednesday. And don't forget, I got office hours on Thursday. So let me know if you have any questions or if I can clear anything up for you. All right. I'll see you next time. Have a good week.